Okay, let's finish up chapter 3. We're going to talk about the division algorithms. I'm going to do a couple of examples of division in other bases, and we'll hit up on a couple of other concepts that need to be finished up here. Okay, so let's get to the division algorithms. Remember that the idea is multiple subtractions, right? And we're going to do this using base 10 blocks to develop kind of the idea of the standard algorithm for division. So first we take a look and remember that this is what we're dividing by, and basically we're looking for groups of 6. Okay, so the idea is you're going to start looking and going through here and seeing how many groups of 6 can you get out of 7 flats. Well, we can take out one group of 6 flats. That leaves us 1 flat, 2 longs, and 6 units. And now what we're going to do is we're going to convert that 1 flat into 12 longs and do it again. Looking at the 6, how many groups of 6 longs can we get out here? Well, we can get 2 groups of 6 longs. And 12 minus 12 is 0 longs, and we're left with 6 units. And then finally we look at it for the units. How many groups of 6 units can we get? We can get 1 group of 6 units. And we're left with 0 units. And so our answer is 1, 2, 1. So 726 divided by 6 is equal to 121. Okay, let's do again with another set here. We have 623 divided by 8. So we're going for groups of 8. Now, right off the bat, we can see that there's 6 flats here, but we need to take it out in groups of 8. So we need to convert all of these flats to longs. So 6 flats is equal to 60 longs, and 60 plus 2 is 62 longs. Okay? And now we pick back up here with our 8, and we look at our 8 and we say, how many groups of 8 can we do here? And 7 times 8 is 56, so we can have 7 groups of 8 longs. And 62 minus 56 is 6, so that leaves us 6 longs and 3 units. Now, we can't put any more 8s into the longs, so just like we did on the other example, we have to get rid of all of the longs and put them over on the units, and that makes us have 63 units. And now we're going to look at how many groups of 8 can we go into 63, and my brain just froze. That's 7 groups of 8 units. Sorry about that. 7 groups of 8 units, and 63 minus 56 is equal to 7 units. Ooh, I just noticed I can draw on myself. That's funny and distracting. Okay, so the answer here is 623 divided by 8 is equal to, and we look at how many groups we have. We have 7, so it's equal to 77 plus our remainder, which is 7 units. Okay. All right, let's go to our next one. The partial quotient algorithm, okay? The partial quotient algorithm requires us to put nothing up here, nothing on top. I know it very much looks like the standard algorithm, but it is not. We're not going to put anything on top. Now, the way that it works is you look at your divisor and think about placeholders, right? We have the hundredths place, we have the tens place, we have the ones place. We also have the thousands place because we do have a number in the thousands. Now 32 already has 2 digits, so if we multiply it by 1,000, it is going to be way bigger than this. So thousands place is not going to help here, but we'll take a look at the hundreds place. 32 times 100, is that smaller than 4224? It is, so I'm going to say 3,200 right here and indicate what this is. This is 32 times a 100. Okay, and then we're going to subtract that, and that leaves us with 1,024. Okay, and that was only one group of 32 that went into that. All right, and now we're at 1,024, and instead of thinking about how many groups of 32 times 10 that can go in there, we're going to do this with repeated subtractions. So we're going to subtract one group of 320, which is 32 times 10. And that leaves me, I did the math here so I wouldn't mess up, 704. Then we're going to subtract another group of 320 because 704 is definitely larger than 320. And that's going to give us another one. That leaves us with 384. And then we can get one more group of 10 times 320 out of there. So 32, or 10 times 32 out of there. So we get that, and we're left with 64. I can keep on going now. We don't have 320, won't go into 64 anymore. Now we're just dealing with the 32, and I'm going to subtract a 32. And that is a 32 times 1, which is also 32 times 10 to the 0 power. I'm going to keep on hammering that one. And then that leaves us with 32, and it looks like we can do another 32 to get us to 0. So that's another 32 times 10 to the 0 power. Okay, now what we do is we kind of count up what we did in each place. So for the hundreds place, we have 1. For the tens place, we have 3. And for the ones place, or the 10 to the zeros place, we have 2. So what that tells us is 4,224 divided by 32 is equal to 132. Okay, let me do another one. And you're welcome to, when you give me some feedback on these lectures, if you think that you don't need 2 examples, you're more than welcome to let me know. Me as a student, I preferred multiple examples because sometimes you can get one and then you get to your homework and there's a problem and you can't think around it. So, but do give me some feedback on that. I would welcome it. Okay, so we're going to do the same kind of idea here. Now, when we go looking at that 800 place, 800 place. Well, we can't multiply this by 100 because 100 won't work. What are our places that we have available? We have the hundreds place, we have the tens place, and we have the ones, the unit place. And the 100 won't work because 8 times 100 is bigger than 623. So all we can do is just start plowing out the 80s. And as you can see, this is going to take a few. So I'm just going to write them all in here so I don't lose them all, and then I'll count them up. So we're going to keep on knocking out 80 until we can't take 80 away anymore. I'm trying to write little because I feel like I'm not going to be able to get it all in here. We're going to have to go over to another column for me to finish it. We're getting closer though. Yeah, it looks like one more. Okay, awesome. So we can't do any more groups of 80. So let's count and see how many we have here. We have 1, 2, 3, 4, 5, 6, 7. All right. So in the tens place, we've been able to pull out 7 of them. I'm just going to write it up there just for now, just because my brain is liking that at the moment. And now we pick up with the 8 and we start subtracting 8s out. And we subtract out the first 8, gives us 55. Subtract out another 8. I'm trying. We'll see. I just wasted so much space right there. Another 8 gives us 39. I'm going to have to go up here. All right, 39. Take down another 8. That's 31. Take down another 8. That's 23. Take down another 8. That's 15. Take down, oh, my bad on that. Let me just erase that little piece. Okay. Take down one more 8, and we're left with 7, and we can't subtract 8 out anymore. Let's see how many of those we have. I count them with a little different color mark here. 1, 2, 3, 4, 5, 6, 7. All right, and then it looks as though we have a remainder of 7. So we can write this as 623 divided by 8 is equal to 77, remainder 7. Okay, and we got that 70 from the 7 groups of 10, and we got the 7 from the 7 groups of 1, and we got that final 7 from the remainder of 7. And by the way, I didn't do that on purpose. I just made up 2 numbers, and that's what it came out to be. So I just rolled with it. Okay, let's see what we got next. The scaffolding algorithm. Okay, the scaffolding algorithm I did not leave enough room for, because if you think about scaffold, you think you're moving up. So I'm going to have to come down just a little bit for it. And I'm going to combine a couple of things here. I'm going to write it in right down here. Hold on, let me. Yeah, I didn't think that one through when I set this up. Okay, so here's the idea. When you think scaffolding, you need to be thinking that you're going to be building upwards. Okay, and we're going to be working now both ends of the equation. So the first thing we take a look at here is the 32, and we say, what place can we go? The biggest 32 we can do is 3,200. So we're going to have to put a 100 up here because it was 32 times 100 gave us 3,200. Now let's see what we're left with. 1,024. And now we're done dealing with the hundreds place, and now we're going to deal with the tens place. 32 times 10, like how many of those can we have? Well, 3 times 3 is 9, so I'm going to say we can have 30 of them, and 30 times 32 is 960. Okay, and I'm just going to make note here, this is 30 times 32. And I'm going to make a note here, this is 100 times the 32. Okay, and so that leaves us with the 64, and 64, 32 goes into 64 2 times. 2 times 32 is 64. And this is 2 times 32, which you can also think about as 2 times 10 to the 0 times 32, as we can think about this one as being 3 times 10 times 32, and we can think of this one as 10 squared times 32. Okay, so you can see the pattern there, and this leaves us with a 0 remainder. And the way that you finish this up is you add them up. So 1 is 1, 3 plus 0 is 3, 2 plus 0 is 2. And that's the scaffolding algorithm. Let's take a look over here and do it again. So we can't really go 8 into 600 or 800 into 600. If we're going to the hundreds place, we have to start with the tens place. And in this case, we can go with 70. 70 times 8 is 560. This is 8 times 70, which is 8 times 7 times 10 to the first power. And let me write it the same way I wrote it on the other one over there, just for consistency's sake. This is going to be 7 times 8 times 10. Nope, that's not very consistent. It's going to be 7 times 10 times X. I'm just trying to be consistent. I know you guys see what I'm doing, but sometimes I want to be correct. Okay, so to do it the way that I did it here was so it would be 7 times 10 times 8. Okay. All right, consistency has happened. All righty, and so when we do that subtraction there, we're left with 63. And then if we go 8 goes into 63, that is also 7 times 8 is 56. This is 7 times 10 to the 0 power times 8. And that leaves us with that 7 as the remainder. And when we add that up here, we have 77, and then we would write R7 because there's a remainder. Okay, awesome. So I just want to make sure that you understand the notation and kind of some of the language. Sometimes that's a sticking point for students. So the form for a division algorithm is the quotient is equal to a factor times a factor plus the remainder, okay? And so what I've done here is I have written out these problems that we've done already. So 726 is equal to 6, which is the divisor, which makes it a factor, times 121, which was the number we got on top, two numbers that multiply together to give us a product are called the factors. So 6 times 121, this is a factor times a factor plus there was no remainder. When we did this, 6 goes into 823. The answer is it goes in 6 is one factor. It went in 137 times with 1 as a remainder. And then 8 goes into 623. 8 times 77 with the 7 remainder. And I also want to point out that all of these are equivalent statements. 6 divided. So this, the way you say this is 6 divides 726. And this has got to be without a doubt the one way that people just really mess up, and we want to say divided by, but that is not 6 divided by 726. That is 6 divides 726. And then the other 3 ways that we generally see it, we would read it as 726 divided by 6 with the usual division bar, or denoted as a fraction, or denoted kind of as a ratio. Let's look at the division and other bases. Again, this is repeated subtraction, and it is tedious for sure. So I wanted to give you at least one nice example, but what I can tell you is it's important to study arithmetic and other bases, because it kind of takes you out of the familiarity that you've developed with base 10 math through all your lifetime, and kind of throws you into something that you have to think a little extra, puts you in the position of a student, and makes it to where you need to learn how to add and subtract and multiply and divide. So it is an important tool, and I hope that you are messing around with it on your own. I hope that you're taking advantage of the fact that there are inverse operations and relationships. You can check your multiplication by doing division. You can check your subtraction by doing addition. So be sure to be doing those things and not just trusting your gut on it. Is that answer right? You know, I'm always checking. Anyway, let's get started here. We have 43 base 5 divided into 3,241 base 5. I did write down the base 5 digits, and pretty much if you go up to about 20, that's going to cover almost all that you might need. You might need 1 or 2 more, but this should take care of it. Now, the first thing I'm going to do is just like I did before. I'm going to start looking at my powers, okay? And I don't know a whole heck of a lot here, but I think I'm going to start subtracting 43 times 10. Okay, so that place, remember that that's where places start over again, right? 10, and then the next place would be 20, and so forth here. So I'm going to start here. Remember, this is just repeated subtraction. So I'm going to subtract 430. And I'm subtracting 430 in base 5. And when we do that math, 0 minus 1 is 1. 3 minus 4 is 1. 4 from, and we've got to borrow here, and this is going to become a 2. And this is going to become a 12. And let's go up here to 12 and subtract 4. 1, 2, 3, 4. That leaves us with a 3. Bring down the 2. We're going to do this again. I'm going to subtract out another 430. Make that subtraction. 1 minus 0 is 1. 1 minus 3 can't do it. Need to borrow from over here. That makes that a 2. Makes that an 11. 11 minus 3, 11. 1, 2, 3 gives us a 3. We cannot take 4 from 2, but we could take 4 from 22, right? And that would be the next one. So let's go from there. 22, 1, 2, 3, 4 leaves us with a 13. I hope you're with me. If you're not, you should pause, go back, watch, come back. I mean, that's the beauty of this for sure. Okay, we're going to do another one, minus a 430. Looks like we could probably do this maybe 2 more times. Let's do it again. 1 minus 0 is 1. 3 minus 3 is 0. Here, 13 minus 4, 13. 1, 2, 3, 4 leaves us with a 4. Oh, look, we can't do it again. We've hit to the 401. Now let's just take a look here and let's see what happened on each one of these and count them up. So they're in total, we did 3 times the tens place times 43. Okay, base 5. So there's 3 of them. Okay. And now we're going to be busted down to the ones place. So now we're going to pick up again. We're going to pick up with 43. We can't multiply it by 10 because that's going to be too big. So now we're going to just start subtracting 43s here. So we get to take 43 here. Now this one is a little bit dicey. I'm going to bring it over here and do the math kind of over here in a thought bubble because I tried to do it in the problem and I had to do it like 3 times. So I'm just going to do it over here and we're doing this in base 5. Let's not forget. And so we have 11 minus 3, 1, 2, 3 leaves us with a 3. Oh, I'm sorry. This was my problem earlier. Okay, can't do that because I got to borrow. Can't just assume we need to borrow here. So from 40, the next number down, if you want to think about it like this, which is a good way to think about it, is going to be 34. Actually, that's probably not the easiest way to think about it, and that might even be wrong. Let's just erase that part. Oh, goodness gracious. Here we go. 401 minus 43. Okay, so let's just borrow like this. So we take from the 4, this becomes a 3, that becomes a 10. That was correct. We take from the 10 and that becomes, what's the number under 10? That becomes a 4 and this becomes an 11. Okay. So now we can do the math here. I'm just trying to get a color going on here. Okay, 11 minus 3. Here we are at 11. 1, 2, 3. That leaves us a 3. 4 minus 4 is 0. Drop down the 3, so this leaves us with a 303. And then I'm going to subtract another 43, and I might just do it over here just for the ease of it since we're going to be borrowing. So I'm going to subtract another 43. 3 minus 3 is 0. This 3 becomes a 2. This becomes a 10. 10 minus 4, 1, 2, 3, 4 is equal to 1. So we get 210. Now I'm going to, let me put that one in there, 303, and then what do we say, minus another 43, left us with a 210. Not quite there yet. Let's subtract another 43 from that 210, so we're at 10. Subtract 3, 1, 2, 3, gives us a 2 here. Oh, I did it again. Darn it. Sorry, y'all. Erase that. Subtract another 43. We've got to borrow first, so I'm going to take from here. That's going to drop down that to a 0. It's a 10. So 10 minus 3, 10, 1, 2, 3, brings us to a 2. We cannot take 4 from 20, so we're going to have to borrow from this 2, making it a 1 and making that a 10. 10 minus 4, 10, 1, 2, 3, 4 gives us a 1, and we have a 1 left over. So we'll bring that 43 down. Looks like we got to do it again. Minus 43. So if I take another 43 here, we're going to borrow from this and make it a 0, make that a 12. 12 minus 3, 1, 2, 3 gives us a 4. Borrow this 1, make that a 0, make that a 10. 10 minus 4, 1, 2, 3, 4, leaves us with a 1. And 14 we can't go any further with, so that's going to be our remainder. So let's count how many of the 43s we were able to take out. 1, 2, 3, 4. So that's just 4 times 10 to the 0 times 43, 5. So that is equal to 4 of them. And then this guy down here is our remainder. And so we get 3241 base 5 divided by 43 base 5 is equal to 34 base 5 plus 14 base 5. All right. Okay. That one was very stressful. Let's get on to the mental computation techniques. The first one is kind of using compatible numbers. So you look at the divisor and you think, is there any way we can set the dividend up so that the divisor goes into something equally? And for this here, we can notice, hold on, we can notice that 105 is equal to 90 plus 15. And that's kind of friendly. And so the way that we would set this up would be 3 divides into, and I know this feels kind of weird and non-traditional, but also in the same note, it kind of makes a lot of sense here. And so we say 3 goes into 90 30 times, plus 3 goes into 15 5 times, and 30 plus 5 is 35. That was kind of cool. Of course, this is a mental technique, and when you put them into those numbers that are easy to compute, they're hopefully easy for you to store and recall in your mind as you're computing them. We'll see. The next one, because I'm not the greatest at that, I'll tell you that for a fact. I need to write down my math almost all the time, but that's because I wasn't trained to do the mental math. Okay, let's look at this one. 8 divides into 232, and this might seem kind of crazy, but 232 is equal to 240 minus 8. So it doesn't always have to be addition. And we know that 8 goes into 240 30 times, minus 8 goes into 8 one time, and so the answer is a quick 29. Which, frankly, I adore versus doing the long division. Okay, another way you can do this, and it's kind of weird, is something called breaking up the dividend, and it's similar to the same thing that we just did, except for it's a little bit more involved. So if we go 7 divides into 4256, the idea is, and of course this only works on really nice problems, but you'll be starting all of this with really nice problems. The idea is that you can split this guy in half. And when you break it up, so to speak, then it's going to become 7 divides into this 4200 plus the 56. Okay, and when we do that way, 7 times 600 is equal to 4200, plus 7 times 8 is equal to 56, so it is equal to 608. And you might think that having to come up with a way to break things up makes it more difficult, but honestly, and I'm hoping that you're learning this as we've gone through chapter 3, kind of being able to do that mental math and check yourself is really nice, especially when we start doing stuff in other bases that you're not familiar with. All right. Finally, the last thing that I want to talk about is the order of operations. Without the order of operation rules that are in place, and I know you've been exposed to them thus far in your career, but without them, 2 plus 3 times 6 could be interpreted in 2 different ways. It could be interpreted in the way of 2 plus the product of 3 times 6, which actually equals 20, and it could be done as 2 plus 3, which is 5, times 6, which is equal to 30. So that isn't going to fly, especially on the foundation of science. So we had to come to some agreement. I say we like I was part of it. This was agreed upon centuries ago. But the agreement was made universally to follow something called the order of operations. And the things that you have to remember about the order of operations, and I know you've seen people arguing on Facebook and other social media platforms about which one is right, and it's a nice long order of operations problem, even a short one. And if you flick into the comments, there's tons and tons and tons of people that have differing opinions. The opinions come from whether or not someone understands the actual rules of the order of operations. I'll tell you that I was very confused about them because I took them very literal, and I never understood that they had to be worked in the order from left to right. And what I would do is I would just skip and jump around there and just do whatever, you know, the division down there at the end. I would go ahead and get that done before I did multiplication. That was earlier in the problem, and I didn't really understand that component. So it is my job for you to understand that we will always be working left to right. And multiplication and subtraction, multiplication and division always trumps addition and subtraction. So in other words, you have to do multiplication and or division first before you do any subtraction. So let's just look real quickly at this. We're so almost done. If you take a look here, reading from left to right, you notice that we've got some division here and we've got some multiplication. And what the rule says is you must perform the division before the multiplication. So, because we're working from left to right. So I'm going to bring down this 8 and this subtraction sign because that doesn't have anything to do with this actual operation of this 9 divided by 3. 9 divided by 3 is equal to 3, and then we still have this times 2 plus 3. Now we go back, starting from the left again, and notice that we have multiplication. Multiplication must be done before any addition or subtraction is done, so we rinse and repeat here, and we have this 8 and this minus, and now we say 3 times 2, that's equal to 6, plus that 3. Now we're all on the same playing field, and we still work from left to right. So working from left to right, you don't want to do the 6 plus 3 here. We're going to work left to right. 8 minus 6 is equal to 2. Plus the 3, and then finally 2 plus 3 is equal to 5. Okay, so definitely take your time when dealing with order of operations. There's a final piece to order of operations, and it's the power of the grouping symbol parentheses. In the hierarchy of order, the parentheses is on top, ignoring all else. If there are parentheses present, you must handle and remove the parentheses by performing the operations inside the parentheses, still following the order of operations. Okay, and I feel like you should be pretty familiar with the mnemonic PEMDAS, or please excuse my dear Aunt Sally. I absolutely encourage you, and maybe that's what I'll do our discussion on, is some of your favorite mnemonics and ways to remember things, but I encourage you to be sure that you know it. So the P is for parentheses, E is for exponents, and we have studied some exponents. We'll get more into exponents as we move out of this chapter. M is the multiplication, D is division, A is addition, S is subtraction, and the very most important thing is you must work all operations from left to right. And another thing that I usually do when I'm teaching this to algebra students and stuff like that is I add one more thing, and I add these arrows, letting them know that those orders can be changed, and I usually do something like this to remind everyone that we do it in the order in which we read, and that multiplication and division can change their spots depending on which one comes first as you're reading from left to right. Same with the addition and subtraction. Okay? All right, well, I think we did it. I know this one was a little bit longer than the last one, but darn that base 5 subtraction, base 5 division and all that repeated subtraction stuff, it definitely ate up some time. Okay, well, I hope you guys have a nice day. Thanks.